everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate First Year Maths B. We started our discussion with limits and continuity. We learned almost all different kinds of limits, right? Today we are going to start infinity limits. That is, we saw evaluating limit from as x tends to a or as x tends to 0 or some other variable or some other number. We have learnt left hand limit, right hand limit of a particular neighborhood limits also, right. What if limit extends to infinity, right? What is the problem if it is infinity? We know that the limit should not be an undeterminate form, that is it should not be 0 by 0, infinity by infinity or infinity or some other kind of undefined forms. Then what if the limit itself to be found if extends to infinity? Tell me how to do. That is, for example, if there is some limit extends to infinity f of x by g of x, something if it is in the form of a fraction, then you have to solve in such a way that make sure that whatever the numerator and the denominator, make sure that you take x as common in the numerator and the denominator. Why? Because as x tends to infinity, I know that 1 by x tends to 0. Is it right? Yes or no? If I take the x or highest power in the numerator, let us see one question. See here, f, the question is in the form of x cube 3x square plus 1 by x cube plus 4x square minus 1, something like this. What is the highest power in the numerator? That is x cube, then I will get it as 1 minus 3 by x plus 1 by x cube divided by x cube. If I take common in the denominator, I will get it as 1 plus 4 by x square minus 4 by x minus 1 by x cube. This both will get cancelled. As x tends to infinity, 1 by x tends to 0, therefore 1 will be as it is. This term and this term will be 0, and here this term and this term will be 0, answer will be 1. Is it right? Did you understand? This is how we'll solve few questions of this exercise. Shall we start? Let's start. Look at these questions now. What is the question? Limit x tends to 3x square plus 4x minus plus 5 by 2x cube plus 3x minus 7. What is the first step we have to do? We have to take the highest degree as common from the numerator and highest degree from the denominator, right. Let us do the same thing, that is limit x tends to infinity. What is the highest degree here? X square, here 3 will be left, either there is only 1, but I have taken 2 as common, which means 1 more x will be in the denominator. Here there is no x square, therefore this will become 5 by x square divided by, here also what is the highest degree in the denominator? X cube, this will be 2 plus 3 by x square minus 7 by x cube. Is it clear? Now tell me, as x tends to infinity, 1 by x square and 1 by x cube always tends to 0, which means this term is 0, this term is 0, this term is 0 and this term is also 0. First let us cancel this. Here also it is 1 by x, therefore this will be 0 into 3 plus 0 plus 0 divided by 2 plus 0 minus 0. However, this term itself is 0, therefore the whole term becomes as 0. Is it right? Did you understand? See here, as x tends to infinity, whatever the term it is, it always tends to 0, that is 1 by x square and 1 by x cube. Okay. Now check the next question. Here he is telling that as limit x tends to infinity, 8 mod x plus 3x by 3 mod x minus 2x. How to find mod x? Mod x is, just tell the rules. This is equal to x for x greater than 0. This is equal to 0 for x is equal to 0. This is equal to minus x for x less than 0, right. Is infinity a positive number or a negative number? Whatever it is, this infinity is always a positive number, that is this is greater than 0, right. Now tell me, for x tends to 0, x is greater than 0, that is mod x is always equal to positive x. You have to write that step, then only you can solve this. Okay, that is limit x tends to infinity 8 mod x is nothing but plus x plus 3x divided by 3x minus 2x, that is limit x tends to infinity 8 plus 3 is 11x by 3x minus 2x is x, x will get cancelled. I will get limit x tends to infinity 11. There is nothing to substitute, therefore answer will be 11. Is it right? Did you understand? There is nothing to substitute here. Okay. Shall we move on to the next problem? Let's do. Look at the next question here. He is telling limit x tends to infinity root x plus 1 minus root x. What is the first rule I have to remember? Whenever I see this root, I have to rationalize, right? Shall we do? See here, that is how to do rationalizing. Limit x tends to infinity root x plus 1 minus root x, multiply and divide by root x plus 1 plus root x into root x plus 1 plus root x. Is it okay? That is limit x tends to infinity a minus b into a plus b, that is a square minus b square divided by root x plus 1 plus root x. This and this both will get cancelled. Okay. That is limit x tends to infinity x plus 1 minus x divided by root x plus 1 plus root x. Now tell me how to solve. 1 by root x plus 1 plus root x. Can I take x common here? That is root x will come outside. Yes. Just check what do we get. Limit x tends to infinity 1 by, we can take x common here, this will become 1 plus 1 by root x and this will be root x. Here root x, here also root x, then we get it as limit x tends to infinity 1 by root x into under root 1 plus 1 by root x plus 1. Is it right? As x tends to infinity 1 by x root as x tends to infinity 1 by x, this is 1 by x, yes, let me write it clearly, this will be 1 by x and 1 by root x also tends to 0. Therefore, this 1 by root x will become it as 0, that is 0 into 1 by root 1 plus 0 plus 1, however it is 0. Is it right? Yes or no? Did you understand? The only thing is here 1 by root x itself is a 0 term. Is it clear? Shall we do one more problem? Let us do. Look at the next question here. Limit x tends to infinity x square plus 5x plus 2 by 2x square minus 5x plus 1. What is the step? That is, I have to take x square common in the numerator, this will become 1 plus 5 by x plus 2 by x square. In the denominator, if I take x square, I will get it as 2 minus 5 by x plus 1 by x square. These both will get cancelled. Therefore, what is left? Limit x tends to infinity 1 plus 5 by x plus 2 by x square divided by 2 minus 5 by x plus 1 by x square. Now tell me, as x tends to infinity 1 by x and 1 by x square tends to 0. Therefore, this will become 0 and this also will become 0. This will become as 1 plus 0 by 2 minus 0 plus 0. Answer is 1 by 2. Is it not easy? But this is very important question. Clear? Whenever you see this kind of question, if numerator and denominator are of same degree, you can directly write the answer as coefficient of highest degree in the numerator and coefficient of highest degree in the denominator, that is 1 by 2. Is it clear? Fine. These are the different problems of limits based on infinity. The next topic we are going to discuss now is continuity. What is this continuity? Tell me the basic meaning. Continuity. right? Yes or no? If I start doing some work, I have to continue it, right? If I do it continuously without stopping, we can tell that is as a continuity form, yes or no, which means we are continuing the same function or we are repeating the function, yes, which means whatever the function it is, for example, if there is some sine function, in order to define whether this is continuing from a particular limit or not, we are going to define its continuity. Is it clear? Whether you understand the basic physical definition or not, remember that we are going to define a limit within this point, that is what about the limit above this limit, what about the limit below this and limit at this particular point. If this left hand limit, right hand limit and the limit at this point are equal, then I can tell that the given function is continuous at this point. Is it clear? Fine. Shall we do few problems on this continuity? Let us do. Look at the next question here, that is f defined by f of x sin 2x by x for x not equal to 0 and 1 for x equal to 0 continuous at 0, right? He is asking whether this function is continuous or not. He is telling that this function is sin 2x by x at non x, that is only at the particular value of x it is 1, except all other cases this is sin 2x by x and this is also sin 2x by x. How to do? That is, first check whether limit as x tends to 0 sin 2x by x. What is the value of this? Do you have any formula on sin? Yes, we have, right? What is it? That is sin x by x. Here there is 2x. What we should do? That is, we have to multiply and divide by 2. Now tell me what is the value of this? 1 into 2, that is 2, right? Is this equal to this? No, right? That is, here limit x tends to 0 sin 2x by x is not equal to f of 0. Therefore, it is not continuous at x is equal to 0. Okay. Let us do the same thing for this problem. How to do? That is, here also f of x, and there are different cases here. This is f of x is equal to x square minus 9 by x square minus 2x minus 3 for 0 to 5, okay, and 1.5 at a particular value of x, which means we have to find the limit of this function at x tends to 3. That is, limit x tends to 3 x square minus 9 by x square minus 2x minus 3. 3 square minus 9 is 0. Here 9 minus 6 minus 3, again this is also 0. Check whether we can factorize it. We can do it, right? This will become as limit x tends to 3 x minus 3 into x plus 3, and in the denominator x square minus 2x minus 3. Here it is 3 minus 1 minus 3x plus x minus 3. Let us take x as common in the first two terms, then this will become x minus 3, and if I take 1 common, this will become x minus 3. This will be limit x tends to 3 x minus 3 into x plus 3 divided by x minus 3 common into x plus 1. These both will get cancelled. I can directly substitute the value. 3 plus 3 by 3 plus 1, that is 6 by 4. 2 3s are 2 2s are 3 by 2, that is nothing but 1.5. Are we getting the same at x equal to 3? Yes. Therefore, limit x tends to 3 f of x is equal to f of 3, that is equal to 1.5. Therefore, f of x is continuous at x is equal to 3. Is it not easy? This is only at a particular point and directly the value is given. What if two different conditions are given? less than a value, I mean less than a point there is a function, more than a point there is a function, at the value there is a function. How to do? Shall we do few problems of that kind? Let us do. See the question now. Check the continuity of f of x is equal to half x square minus 4 for x less than, I mean 0 less than x less than 2, 0 for x equal to 2 and 2 minus 8 by x cube at x greater than 2, which means we have to find 3 conditions, that is limit x tends to 2 negative, limit x tends to 2 positive and limit x tends to 2. Okay. Now see here, that is LHL limit x tends to 2 negative f of x is equal to limit x tends to 2 x less than 2, x tends to 2 negative is the value less than 2. What is it? X less than 2 is half x square minus 4. The function will be half x square minus 4, that is equal to half into, substitute 2 square minus 4, that is half 4 minus 4, 4 minus 4, this both will get cancelled, I will get it as LHL as 0. The next is I have to find RHL, that is RHL right hand limit, limit x tends to 2 positive f of x is equal to limit x tends to 2. What is f of x for x greater than 0? 2 minus 8 by x cube. Just directly substitute the value, this will become 2 minus 8 by 2 cube. Okay, we can write it as like this. Okay, 2 cube is, how much is it? 8, both will get cancelled, 2 minus 1 is 1. Are these both equal? No, right? So, let us find the value of f of x is equal to f of x at x equal to 2, that is f of 2 is equal to 0. Now, tell me this value is equal to only LHL but not equal to RHL, that is limit x tends to 2 negative f of x is equal to f of 2 but not equal to limit x tends to 2 positive f of x, which means only LHL is equal to the function. Therefore, we can't say it is completely discontinuous, that is it is left continuous, we can write like this, left continuous for x equal to 2 or at x equal to 2. Is it okay? Similarly, let us do it for the next question. Here, if f of x is equal to k square x minus k for x greater than or equal to 1 is 2 for x less than 1, he gave that this is continuous on R, which means this is continuous throughout the real numbers. He is asking us to find the values of k. How to do? One thing we know that this should be equated to, I mean all should be equal. Okay, what is that we have to do for the first? That is LHL limit x tends to 1 negative f of x. What is it? Limit x tends to 1. What is f of x for 1 negative? That is x less than 1, that is 2, answer is 2. There is no variable to substitute. Yes. And the next RHL limit x tends to 1 positive f of x is equal to limit x tends to 1 positive. What is it? That is x greater than 1. This is k square x minus k. Yes, that is equal to k square into 1 minus k, that is k square minus k. Okay. They gave that this is continuous, which means this is continuous throughout R, which means LHL should be equal to RHL. Okay. However, even if we substitute 1 also, this is the same thing, right? Yes, since f of x is continuous on R, that is it is continuous on x equal to 1 also. Yes, therefore, LHL equal to RHL. What is LHL? 2 is equal to k square minus k. Let us write everything to one side. K square minus k minus 2 is equal to 0. What are the factors? This is let us write it as k square plus 2k, I mean minus 2k plus 1k minus 2 equal to 0. Let us take k common here. This will become k minus 2. Let us take 1 common here. This will also become k minus 2. If I take k minus 2 as common, I will get it as k plus 1 equal to 0. Therefore, the values of k are minus 1 comma 2, right. This is easy to understand, but very important question. Clear? Shall we do one more last problem? Let us do. See the question here. He is asking us to show that f of x is equal to cos ax minus cos bx by x square at x not equal to 0 and half b square minus a square at x equal to 0 is continuous at x equal to 0, where a and b are constants. It is okay, right. How to do? First of all, as limit extends 0, we have to find the limit of this, we have to get this answer. Do you remember this question? Yes, right. Yes, that is, first of all we know the limit of that. So, I will do it a little bit fast as compared to the before. Okay, fine. Just check it here, that is limit x tends to 0, f of x is limit x tends to 0 cos ax minus cos bx by x square. How did we solve cos a minus cos d, right? Minus 2 sin c plus d by 2 into sin c minus d by 2 divided by x square. Therefore, let us write it as x and x. Okay. And the next step is limit x tends to 0, minus 2 will be outside, sin of a plus b by 2 into x divided by a plus b by 2 into x. Why? Because there is only x in the denominator, I have to multiply and divide it with a plus b by 2. Okay. And the next thing is limit x tends to 0 sin a minus b by 2 into x divided by a minus b by 2 into x into a minus b by 2. Now, tell what is the value of this? Limit x tends 0 sin x by x, that is 1 minus 2 into a plus b by 2, again this is also 1, the left out is a minus b by 2, 2 is cancelled, minus a square minus b square by 2, this is a plus b into a minus b, that will become as a square minus b square, minus multiply inside, this is b square minus a square by 2, that is nothing but half b square minus a square. What is this? This is f of x at x equal to 0, that is nothing but f of 0, right. Therefore, f of x is continuous at x equal to 0. Is it clear? Did you understand this problem? Fine. By this problem we have ended the chapter limits and continuity. Hope it is easy and simple to understand, right. What is that we have to remember? In the basic thing, we have to remember that the answer should not be in undeterminate form, and the second thing we have to remember all the basic rules of limits, and in the final continuity just I have to substitute LHL, RHL. Clear? Fine. This is for today. Let us meet in the next session with the new chapter of 1B. Thank you.